Okay, in this video I'm going to continue on with my tutorials on thermodynamics and statistical mechanics. So this is number 28 and I'm going to discuss entropy versus energy graphs, which we introduced in the previous video, which is number 27, where I showed the relationship between temperature, energy and entropy. So temperature is the inverse of the del S del U, or the rate of change of entropy with respect to energy, or the inverse of it is equal to temperature. In number 26 I discussed entropy, and we showed that S is equal to K log omega, where omega is the multiplicity. And number 25 I discussed the second law of thermodynamics. So it's time now just to do a very short video on the entropy versus energy graphs. So most objects, the temperature of most objects increases with increasing energy. So you think about it, if you put more energy into an object, it gets hotter. So energy, if you up the energy, you up the temperature. Now that's our observation. The question I have to you, or the question I pose to you though is, do we understand everything? Does our physical intuition or observation or experience explain everything, or is it exhausting? Is it exhaustive? And the answer is no. And if you want to look at my video on wave particle duality, you'll see of course that everything we do is based on our own experience. So I'm telling you that it's possible for something to get colder as the temperature or as the energy increases. So let's just look at that right now. Alright, so increasing temperature. Well, that corresponds to so if the temperature goes up, well then the S versus U graph goes down. So it's concave down. Increasing temperature, concave down. Alright? That's what increasing temperature is. Now, this is because the body with the large del S, del U at constant N and constant V, okay, will readily accept energy. And the body with the low, and as a result it's a low temperature. Just to remind us, we saw in the previous video that temperature is equal to del S del U, the inverse of del S del U, constant particles, constant volume. Okay, so if it's got a large slope of del S del U, well then it's at a low temperature and it will readily accept energy. Now, let's start plotting some of these graphs. So if I plot a graph like this, if I plot S versus U, okay, this is what we call normal. Okay, because, well, it's normal because del S del U is going down. Okay, del S del U is going down. As the temperature is increased, the slope is getting smaller. Okay, that means temperature is going up. So the temperature is going up as the slope slowly gets smaller. Okay, or the rate of change of S with respect to U slows down. And that's what we call a normal system. And in life, your kettle, for example, will operate that way, because that's what we understand. We've seen that. So that should be no big surprise to anybody. Now, what happens if instead the body is a concave up? Like, is that possible? I'm telling you it is possible. Of course it's possible. And we just don't see it on a normal day-to-day basis. So let's say it's concave up. Well, if it's concave up, what is getting larger? Well, del S del U is going up. The rate of change of S with respect to U is going up. Okay, therefore 1 over del S del U, which is the temperature, is going down. So the body is getting colder. So as the energy increases, the body is getting colder. Now, I'm going to tell you that that is because energy is stored in potential. Okay, and this happens if you're into astrophysics. then this is the sort of system you will see when you're looking at nebulae and so on. Alright? See, the system getting colder as energy is put in, because what's happening is the energy is going into potential energy rather than into kinetic energy. And kinetic energy is heat, so if it doesn't go into kinetic energy, it must go into potential energy, and as a result the system gets more energetic, but it's actually getting colder because there's less kinetic energy. And finally, well, what happens if the S versus U is constant? Let's see that the third and final graph. So there's U, there's S, and it's constant. Well, del S, del U is constant, and therefore the temperature, of course, is constant as U goes up. So as you increase the energy, the temperature stays constant. Think about it now. In our own experience, what system behaves such that its temperature is constant as the energy goes up? The answer is a phase change. So you boil a kettle, going from a gas to a liquid, from a liquid to a gas. You're increasing the energy, but the temperature is still staying the same. So that's one we've seen before. So I think I'm going to leave it there. So that's all I've got to say. That you have three types of bodies. You have one where your phase change is where del S del U is constant. Where del S del U is getting smaller, the temperature is getting bigger. And when del S del U is getting bigger, the temperature is getting smaller. And that is the interesting one in stellar astronomy. Alright, or not stellar astronomy, excuse me. Well, it could be stellar astronomy, but let's say talk about nebulae. That's a good example. So, thanks for watching. Please pass it on to your friends, subscribe to my channel, and if you're in a good mood, you might also click on an ad. Thank you.